Have you ever wondered why now seems so fleeting and how it fits into our understanding of time? It's a question that might seem a bit abstract, but it's rooted in the very fabric of our reality. You see, now is not a fixed point in time, but rather a relative concept. It's influenced by a myriad of factors that might surprise you. Consider for a moment the impact of speed and mass. According to the laws of physics, these two elements can warp our perception of now. For instance, time passes more quickly at higher altitudes and slows down at lower altitudes due to the influence of mass. It's a concept that seems almost surreal, doesn't it? And yet, these are the building blocks of our universe, the invisible forces that shape our experience of now. They mold and shape our perception, creating a now that is uniquely ours. So, as it turns out, now is more complex than we might initially think. Did you know that time behaves differently depending on where you are and how fast you're moving? It's a mind-bending fact, but time doesn't tick at the same rate for everyone. Instead, it's influenced by factors like speed and mass. Consider this. Time actually passes faster at higher altitudes than it does at lower ones. Sounds crazy, right? But it's true. If you're standing on top of a mountain, a second for you is slightly longer than a second for someone at sea level. This phenomenon, known as time dilation, is a prediction of Einstein's theories of relativity. Einstein's theories on gravity and speed have shown that time is not uniform. This means that objects, or even people, experiencing different speeds or gravitational fields will also experience different durations of time. This may sound like something out of a science fiction novel, but it's a scientifically proven fact. So, next time you're running late, just remember, time isn't the same for everyone. Ever noticed a delay between seeing a lightning bolt and hearing the thunder? That's relativity in action. The light from the lightning reaches your eyes almost instantly, traveling at a mind-boggling speed of nearly 300,000 kilometers per second. Sound, however, is a bit of a slowpoke in comparison, clocking in at a mere 343 meters per second. That's why you see the flash before you hear the rumble. This delay is more than just a neat party trick of nature. It's a fundamental part of our perception of time. It takes time for information to travel, whether it's light from a distant star or the sound of a nearby explosion. This travel time creates a lag between when an event actually happens and when we perceive it. That's why, when you're watching a distant firework display, you'll see the explosion of colors before the bang reaches your ears. So even our perception of now is influenced by the speed of light and sound. Albert Einstein didn't just give us E=mc squared, he fundamentally changed our understanding of time. The man with the wild hair and the chalk-covered hands, who's become a symbol of genius itself, has left an indelible mark on how we perceive time. His theories have unraveled the tightly knit fabric of time, revealing it as a dynamic, fluid entity directly influenced by factors such as speed and mass. Einstein proposed that time is not uniform but relative. It slows down or speeds up depending on how fast one thing is moving relative to something else. Imagine a clock at sea level and another on a mountaintop. The higher clock would run faster than its lower counterpart. This disparity, known as time dilation, is a direct consequence of Einstein's theory of general relativity, which postulates the influence of gravity on time. His ideas have transformed our understanding of the universe from a static, absolute framework to a dynamic, relative one. They've made us question the very nature of reality, forcing us to let go of our innate belief in an absolute, unchanging now. Thanks to Einstein, we now know that time is far more complex and intriguing than we ever imagined. So, if now is so relative and complex, what does it really mean? Well, let's delve into that. In the grand scheme of our universe, now is a slippery concept, always on the move. It's like a wave in the ocean, constantly shifting and changing with the ebb and flow of time. It's not a static point, but a dynamic one, influenced by a myriad of factors from our speed to our position in relation to mass. You see, now is a living, breathing entity within the body of time, fluttering like a butterfly from one moment to the next. It's not as straightforward as it seems. It's not just the present moment as we perceive it. It's a complex interplay of past, present, and future, all happening simultaneously. Yes, it's mind-boggling, but it's also incredibly fascinating. Einstein's revolutionary theories have reshaped our understanding of this concept, allowing us to see now not just as a simple tick of the clock, but as a journey into the heart of relativity itself. So next time you think about now, Remember, it's not just a moment in time, it's a fascinating journey into the world of relativity.